This function that I'm going to show you is I'm going to show you how to take a voltage AC measurement and secondly how to measure frequency. As you can see, my black test lead is in my common port and my red test lead is in my function port. If I take my black test lead, I'm going to connect it to my neutral wire. I then take my red test lead and I connect that to my live wire. I now take my rotary dial, my Fluke 177, and I turn it over to the voltage AC side. If you look over here, you can see I'm measuring 234 volts AC. In this function, you can also see I've got an HZ signal, which stands for Hertz, the unit of measuring frequency. For me to enable this function, what I've got to do is I've got to press the yellow function key, but by pressing it, you can now see I'm measuring 50.13 Hertz. Okay, the next function that I'm going to show you is I'm going to show you how to measure resistance measured in ohms. On my electronic board here, I have 4 resistors and let's measure the resistance on each one. The first thing that I need to ensure is that my electronic board is de-energized, which it is. I now need to measure over my resistor. 329 ohms, almost 330 for the first one. Same for the second. Alright, we are now going to measure capacitance. I have 2 capacitors here. One is 25 microfarad and one is 35 microfarad. I know for a fact that one of these has failed. The first thing that we need to do is we need to turn our rotary dial over to our resistance and capacitance function. The capacitance function is highlighted in yellow. I need to press the function key so that it is now moved over to the capacitance function. I then take my test leads and I put them on the ends of my capacitor. This one I'm measuring 24.7. This is my 25 microfarad capacitor. So this one to me is working perfectly. It's within this 5% tolerance specification. This unit over here is my 35 microfarad capacitor. Oopsie, it's only measuring 7 microfarads. This unit has failed. The next function that I'm going to show you is I'm going to show you how to take a continuity measurement. What a continuity measurement is basically a fail or a pass function to see if your circuit is complete or not. The first thing I'm going to do is I'm going to move my rotary dial over to my continuity function over here. My black test lead is already connected to the end of my wire. You should hear a buzzing sound if the wire is complete. We can see now that our circuit is complete. If our circuit was not complete, this is what happens. The buzzing function now will go away as soon as I cut the wire. Okay, the next function that I'm going to show you is how to take a measurement of current amps AC. The first thing I need to do is I turn my rotary dial all the way over to amps AC. I have my black test lead connected to my brown live wire and I have my red test lead connected into my live terminal. This allows current to flow through my meter, being able to take the measurement. I now need to switch my circuit on. And if you look at the screen of my meter, you can see if we just waited for it to settle, I'm measuring 0.070 amps AC. The next function that I'm going to show you is I'm going to show you how to check for basic power quality using the min, max and average function key. For this particular example, we are going to move our rotary dial to voltage AC. I'm going to connect my black test lead to my neutral point, and I'm going to put in my red test lead to my live. You look on the meter, I'm measuring 234 volts AC. I'm now going to press the min, max and average button so that I'll effectively be monitoring for my minimum, my maximum, and my average voltage. A good example of this is checking out for voltage dropouts or voltage distortions. If I switch off my system, You can hear the meter makes a few beeps. It's basically indicating to you that it has new values that it's monitoring. If I look at my maximum value, I have 234 volts. If I go to my minimum value, here I have 11.8. This is an indication to me that my voltage has dropped off during some point of the measurement. If I press my average, that is my average voltage over time.